Good morning, everyone. I hope everyone is doing okay. And for some of you, it may be very early morning. I can see people joining from US, a lot of people from India. So good afternoon. I hope everyone is doing okay and ready for another exciting day for BeSA program. Uh, my name is Ashish. Hopefully, you know me. Some of you may be joining for us today. So I'll quickly go through what we are going to talk about. What is this BESA program? And let me also welcome my colleagues who are here. So I have Alex with me. Alex, then I have Chris, and then James is also with us today. So we have almost full house. Jamila is also joining. So hopefully you can see all of us, and we are all here to help you and give you answers of the questions you may have. So keep asking questions. Everyone is monitoring chat. We would respond back to in the chat. And in case we forgot to mention or answer any question, reach out to us on LinkedIn and we would be happy to answer the question. Right? All right, good. So everyone is excited, hopefully, and everyone has watched the last video and understood what we are going to cover today. We will talk about storage and lots of other stuff. Hey, Jamila. So this is my colleagues. One more is missing, Prasad. So probably he would join us next week, and we will also talk about lots of interesting stuff today. This video would be recorded and would be posted on YouTube. And after some time, maybe after an hour or so after the live session. So in case you are watching it later, you can find it on YouTube. And if you see something, say something. If you like something here, which interests you, which you found interesting, or which you think should be shared with others also, so feel free to take a screenshot, put it on LinkedIn, share us, tag us, so that we can reach out to more people, and that's the intention we have for this particular program. All right, thanks everyone. I'll now get started with the content and I'll talk about what we are going to discuss. I'll let you focus on the screen rather than on my expressionless face. Loud and clear. Okay, thank you. Yeah, maybe I need a little bit more coffee in my system right now. It's not very late, not very early, sorry. It's 9 o'clock in London. Yeah, but I woke up a little late and maybe a little more lazy. Hopefully, I won't have that kind of issues anymore. I will be fully alert. So, what I'm going to discuss today, I'm going to talk about these service models, accessing AWS services, storage services, then getting started. And we will talk and listen from essays who would talk us through what are the services and how they actually utilize into the system. So we will talk about using Amazon S3 for IoT. Jamila will walk us through that. And then Alex will talk about some reference architecture related to Amazon S3. So this is what we are going to discuss into this particular training. Right. Let me start with this module and hopefully everyone can see it. As I said before, like if you see something which is interesting, feel free to share that on LinkedIn, maybe take a screenshot, maybe share something you learned here with everyone so that community gets informed and they know about this program. They can later watch the YouTube videos or maybe join the live session. So most people get benefited. That's our intention is. So quickly talking about what the program is. Program is in BESA. Uh, Karbal, thank you for joining from 3 a.m. You need coffee too, exactly. Talking about the core team, Alex, Ashish, Chris, Jamila, and Prasad, we are the core team, and we are being helped with Andy and James, who is the extended team. We will be sharing a lot of stuff because we are passionate about helping community and giving back to community. And we will be doing this live 8 a.m. GMT every Saturday. And these are some more links which you can find on our BESA page, which is related to recorded videos, resources, what communication channel would be used. Plus stages, there would be 2 stages. What we are currently going through is a technical track, which is open to everyone. But then later we will talk about how we will filter people for the behavioral track, and we'll try to take as much as we can. But right now we are putting a limit of 20. But let's see if we get more help from AWS, we would be able to add more people into this particular program, right? Now, what is the cost for this? Answer is no cost for this particular program. It is free. But if you use your AWS account for practicing what we discuss here, then you may have to be aware about that cost. So I'll talk about some of the stuff today. Okay. Now, let's talk about what intended audience are. Intended audience are people who are trying to become a solution architect, who may have some IT skills but may be pretty new to cloud or have very basic understanding, and will try to help you in gaining more understanding about AWS Cloud. That's what we are planning to target this session for. And this is not a job guarantee program. This is not affiliated with AWS. We are doing it voluntarily, and the views shared by us, our own, they do not represent our employer. And if there is a conflicting information, please check into AWS official documentation. And program is run on best effort basis. We are getting a lot of LinkedIn messages. We try to respond as much as we can, but just in case we forgot, please feel free to remind us. We don't mind. Just remind us again and we can look into query. But if you think that we would be able to help you design something or review the code of 10 pages you have written, probably not, but we will try our best. Let's go ahead and start with this. Okay, now we will talk about service models. I want to ask a common question to people around here. Like when we talk about web services, when we are talking about this is a server or this is this and that, most of the time we use a word again and again called service. So can you please let me know what is your understanding of service? What do you think is a service? Very basic. I'm not looking for bookish definition, not looking for Wikipedia definition. If you have to explain a 10-year-old what is a service, what you would say? An API? Yes, Evans, that makes sense. API is a way to access a service, I would say. Give a request and get a response. Exactly. Service is helping you to get something out of it. Yes, API is there, so that's true. And something that helps us. Exactly, Jay. So it could be anything, right? Something which is satisfying the need. Yeah, that's also true, Venkat. What else? Getting some input and giving some output. Exactly. Something you can get something from. Yes, I like that definition. And that serves a specific purpose. Exactly. So yes, you are on right track. I define service very easily or in a way that everyone can understand. Something that helps you do something, right? Fulfilling of the requirement. Exactly, Neetu, that's what we are looking for here. So some service is basically helping you to do something. Example could be you are having some products delivered to your home. That is a service. A company has picked up product from somewhere, a warehouse, got your address, got the package for you, delivered it, took a screenshot of the delivery, responded it back, and then the system recorded that the delivery was successful or the person was not available, and we will reattempt the delivery next time. So that's a service, very basic sense, right? If I have a coffee machine in house, I would say that is also a service, right? So I provide some raw ingredients to this coffee machine, maybe water, maybe coffee beans, maybe milk, and then it would prepare a cup of coffee for me. That is again, I would call a service. But this service I am using on a self-service basis. What if I want to have a coffee and then I prefer to go to a cafeteria? So there would be a barista qualified who would be able to make coffee for me, and I'm pretty sure it would taste better than my homemade machine. So probably I would go there. But if you are going to a restaurant, that is not just serving coffee. It is the service which is around it, right? Like you would have a good sitting place, you would have a nice ambience, you would have people to talk to, maybe a good Wi-Fi speed, maybe little magazines to read into. That's all we are trying to utilize. BeSA is a service, exactly, Jatin. I like that. So yes, exactly, that is a service which we are offering, and it is free. Don't worry about charges. So service hopefully is idea. This is allowing us to achieve something by providing something to us. That's what a service is. Now, when we talk about cloud, cloud has different mechanism. I was reading some comment and some people are talking about infrastructure as a service, then software as a service. So I'll try to demystify that thing by taking a very, very basic example. I would talk about how service models are different, and let's talk about pizza as a service, right? Probably everyone likes pizza. I don't like pineapple pizza, but other pizzas I like. I'm a vegetarian, so my choice is limited, but I exactly like pizzas very much. So let's see how pizza as a service can relate you to understand some of the basic concept. You have a carving for getting a pizza, right? You want you hungry now, pizza da? So probably you will have pizza. That's good. So let's say we want to have a pizza. Let's see what options we have. One option for me is if I am very good at cooking, I would make it at home, right? But my experience with kitchen is maximum up to boiling water for tea, nothing beyond it. So probably this wouldn't work for me. Make it home won't work for me. Another option is I can buy it from a supermarket and bake it at home. So I take pizza from a supermarket and bake it at home. Third option for me is that I can ask a pizza to get delivered to my home. Lots of apps available, Deliveroo or Uber Eats, and I can get my pizza delivered for myself. Or if I'm willing to go out and if weather is nice in London, I would probably go out and eat out, right? So same thing, intention is I want to have pizza. What are the options? These are the multiple options which are available. Let's see what are the way these relates to our cloud services. So if I'm making pizza at home, what I have to do, I have to take care of all these things, like the drone delivering is good. So cheese, topping, then tomato sauce, pizza dough, fire, oven, electricity or gas for it, soda, and a dining table. I have to arrange all these things, then only I would be able to make pizza. So these are the basic things which I have to take care when I am making pizza at home. When I'm taking and baking things, right? When I take pizza from a shop, which is like a frozen pizza which I got. So what happens here? In this first case, I was managing everything from cheese to topping up to fire up to dining table. But when I take a pizza from shop, somebody has already prepared it for me. Pizza dough is ready, tomato sauce has been put on that, there is a topping, there is a cheese on it, so they have taken care of this. That is been managed by the vendor, right? So that is vendor managed pizza. We will talk about how these relate to infrastructure or software. Just give me a minute, I'll come back to that point. Now if I have this pizza taken from outside, I still have to take care of fire. So I have to heat it. I need electricity and gas for that. I would be looking for soda and probably a dining table where I can easily sit and eat my pizza and enjoy it. So that is one of the model which we have. If I am talking about pizza delivery, then if you see, my responsibilities are becoming lesser and lesser, isn't it? Right. So what I'm doing here, I am not utilizing anything now. I don't bother about electricity. I am getting my pizza delivered. So what I may want to have now, maybe just the soda and a dining table. That's all I have to worry about. I have to have these things. But in case we have intention to go out, then we do nothing at all. We do not need to prepare at all anything. I'll go to a restaurant. Probably I may have to book a ticket if it is book a table if it is too busy time of the year. I would go there, get my pizza, pay the money. That's all. I do not worry about at all anything. Right. Hope everyone is following the analogy. Yes, Jay, just eat. Now, what we are trying to achieve here, if I explain this from now computing perspective, the very first one, make it home, is a traditional on-premises approach where you take care of server, networking, component, install it, configure it, maintain it, operate it. That is what you are doing. That's all we call traditional approach on premises. Second, when I'm saying taking and baking it, so that I can relate to infrastructure as a service. Somebody has created infrastructure for me, a pizza, and then I use it, but I am adding my own things in that. So maybe my own fire, I may want to bake it crisp. I may want to keep it little simple, little less baked. It's up to me, but I have control. That is what my infrastructure as a service is. Next one, when I'm getting a pizza delivered, that I can think is a platform as a service. A restaurant has provided a platform where I can go and order and I can get my pizza delivered. Somebody would deliver. That's what my platform as a service looking like. And when I'm eating out, like you were a lot of people were saying exactly, then fourth one is software as a service. I'm just getting my pizza and that's all I'm worried about. So hopefully everyone got a little idea that how all these things relate to. So I try always to explain technology from day-to-day life perspective, because technology is not coming from space. It is being developed from the processes we already know about. Yes, we may have to peel out things a little bit more to understand it, but technologies is not very different from your real life stuff, and we will keep on talking about these stuff as we move forward, right? So these are my service models. Now let me now paint the same picture in your actual computing platforms. So if I have a traditional server on premises, I would take care of networking, storage, virtualization, everything would be maintained by me. That is my on premises infrastructure, right? If That is what I am managing for this. If I say I would rely on a service provider, which is a vendor who would give me the servers, who would give me storage and networking, and on top of it, I would install my own operating system, my own middleware, and then runtime environment like Java. I would put my data and then I would run my application. So that's how we would call this is a approach of infrastructure as a service, right? Hold on for that, Daniel. Maybe 90 more minutes and then you can have your pizza. So infrastructure as a service. Now, this is more aligned to administrators. Now, I'm not saying that only admin would be interested in that, but most of the time, if I'm a systems admin, this kind of approach would align more to me because I am utilizing infrastructure provided by someone and I just use it. Now, in the second approach, what I may have that I may start using services provided by the vendor and I just take care of my application and data. That's all. This is what I mean by platform as a service. So I want to run a code of Java. I have a Java code written, maybe I have a Docker container image of that, and I want to push it to a platform and get ready to deploy and run that. That's what my platform as a service would be looking like. So that's called platform as a service. And who would be interested into platform as a service? Probably developers. Right. So developer who want to run their code, who want to manage their infrastructure in automated fashion, they would be more interested into this. That's all a developer would look like. Right. Right. Now, last one is where everything is managed by the vendor. I just take care of just using the services, right? Like currently we are utilizing Twitch to stream it. Later we would use YouTube to push this video, and maybe we are using LinkedIn to message people around that what they want to use. So that's the exact same thing is happening here, that we are trying to utilize this software as a service. Somebody has installed the software for me and I just utilize it. They maintain my data for me, they store my video like YouTube is storing my video, and I just utilize all these type of stuff. So that will be called as a software as a service. So Cloud9, we consider it platform as a service. I would say that yes, and I would also put it in a software as a service, Parna, because in Cloud9 I can go and write my code. Elastic Beanstalk, yes, good example, Sebastian. That is a platform as a service. Exactly. So yes, that is what a platform as a service is looking like. So this is a software as a service. And this would be more concerned for end user. If I'm an end user, I would be focusing more on this kind of stuff where I want to get a software delivered, like you are utilizing Twitch, you are utilizing YouTube, you are utilizing Netflix. These are all your software as a service given to you. Office 365, great example, Katara. Abhishek, that is exactly great example of what a software as a service is looking like. Slack, exactly. Slack is a software as a service. So hopefully everyone is clear. Now let's see if we have get all this infrastructure. Fargate comes under software as a service as a platform as a service. I would say it's a platform, Devashish, but I am trying to explain one more thing here. AWS doesn't differentiate anymore between these. We all say that these are building blocks. You will not find a lot of documentation which is new, which talks about IaaS or PaaS or SaaS, because the line is becoming blurred day by day, right? The line is becoming so thin, so undifferentiating that there is no point to talk about it. Let's call everything as a cloud service. We call them building blocks, like a Lego. Like when your son or daughter is playing with Lego, they may make a small house from it. They may make a giant Robocop from that. They may make a small, just a brick from that. So it depends. So these Lego blocks are there, and you decide what you want to make from it. Obviously, they need to be arranged in a different fashion. They need to be arranged into a different format, but the basic component remain the same. That is what our AWS services are. All right. Let's move forward. Can you explain more why, whereas why administrator will be interested in infrastructure as a service? Why? Because if I am a admin, right? So I have to take care of racking and stacking of the servers. And if I have to expand it, then I would be looking for having more physical space to put my server. And why I would be interested in, maybe I am deploying a operating system which is pretty unique to my needs, which is pretty customized for my need, which a cloud provider is not offering. Maybe I want to run Solaris. So I want them to give me only the physical hardware, and then I would install my own controlling mechanism on top of it. So if I'm looking for more control, that time I would be providing this kind of service like infrastructure as a service. So admin would be taking care of infra, right? So exactly. So that's how you will take care of that. All right, so these are understanding, but these infrastructure platform software, the line is getting blurred day by day. So that's why I would say I won't go deep into it. There is no point, because for some it may look like a software as a service, for other it could be treated as a platform as a service. So just get the idea, but we will talk more on how to consume these particular services. Okay. Now, so that's fine. Now, AWS offers you lots of services. So my question is, how we get started by using these services, what you would be utilizing and accessing your services, right? So let's see how accessing of AWS services would be working for us. Let's get started on that. So AWS services are web services. The full form is Amazon Web Services, which means you need a web service communication channel, which is your browser or maybe some other mechanism to send your HTTP request to an endpoint, which is AWS endpoint, and who would respond back to you. That's what a AWS service is. Now, to access this AWS service, I can use different methods, or my interface to access a AWS service could be different. These are the three commonly used interface mechanism for AWS service access. The middle one talks about AWS Management Console. What is this AWS Management Console? AWS Management Console is a browser-based interface by which you access AWS services. So right now I am into a AWS Management Console. This is my browser, and through this I am connecting to console.aws.com, and I am pointing to EU West 1, which is a Ireland region. So this is a front end by which I would be communicating to AWS services. So that may be a easiest way to get started. That is your management console, right? Second option, what if I have to do lot of command line stuff? What if I have to use some commands and run some automation, put some script? So in that case, what I can do, I can access AWS services even from a command line. I would need to install some tool, and that tool is called AWS CLI. And through that, I am able to get uh, work done. So I'm checking AWS version here. I have a tool installed called AWS CLI, which is available on Windows or Linux platform, Mac OS also, which you can install. And through this, I can run my command, as we can see. So we can check that AWS CLI is available, and we can use it for any other stuff. So AWS, probably this is the command version. So this is a software developed into Python, and by which I can run command against AWS infrastructure. I have a CLI version 2.2.9 installed here on Windows 10 machine, but it can be on a Linux or any other machine also, no problem at all. So that is another interface. Third option, when I am a developer and I want my programs to communicate or my front end to communicate to back end, that time I would be using AWS tools and SDK, and these tools and SDK would allow me to communicate to the back end. So I would write a API call, and that API call would be going to the service, respond back, get authenticated, and then I would be able to get my stuff done. So these are the three interfaces for communicating to AWS. Right now, yes, Vivek, PowerShell is also available. You can use that. Front end could be anything, but at the back end, whatever is going on, it is an API. So what is happening here? That everything is coming up with a API request with that. So whatever you do, whether it is a command line, whether it's a management console, or whether it is your tools or SDK, everything is coming through API, and through API I am able to utilize my application. So front end could be anything, but back end is going to be an API by which my services would be connected, and we publish API endpoint, which you can also get hold of. So let me quickly give you one command here. So I'm going ahead and saying AWS EC2 describe regions. EC2 is a service. We will talk about it next session. But this command, when I'm running, this command, when it's successfully run, it would tell me that what are the regions available into AWS to connect to. So you can see EU EC2 EU West 2 is EU West -3 is the endpoint. So whenever I am in my browser selecting EU West 3, my requests are basically going to this endpoint of EU of EC2 service. This is the EC2 endpoint, and similarly for every service there is an endpoint. Some endpoint are regional and some endpoints are global. We will talk about them, so we will see that. Now I'm seeing a lot of communication happening in the chat about Boto. Boto is a library we use for communication. So what is Boto? Boto is our way of communicating and getting our stuff done. So Boto helps us in getting our applications ready. So Boto is a library. Now there is a quick history I can give you. Boto is a name of a dolphin, and the dolphin is found into Amazon River. So some of our developer thought it would be better to give our Python libraries name of Boto. So Boto is a dolphin found into Amazon River, and which is the name given to our libraries which you use to communicate using Python to AWS services. So hopefully everyone is clear and understood what is Boto. But don't worry that we will discuss more on that when the time comes. We'll talk about it. Okay. So API, hopefully everyone is clear what is API and how it communicates. Yes, exactly, Nivedita. Exactly. Now, AWS Global Infrastructure, we discussed this last time, right? We talked about that, what are the regions, what is the availability zone, what is the edge location. Then we talked about how these communicate, and what we are going to talk today, we are going to talk about foundational services. Boto 3 is a version, QWS, it is a version. So version can be different. Obviously, we keep on updating versions and libraries, so performance is better, the improvement in security. So Boto is the name, and 3.2.1 would be the versions associated with it. Same like any language has a version, exact same thing we are going to do here, right? So hopefully this is everyone's idea. Now, what we are going to discuss today, we are going to talk about storage. Storage is a very, very important aspect of whatever you do. So we need to talk about what is going to be storage. Vijay, the slides are not moving. Are you still showing IAS? No, I am very far from that, Vijay. So probably you have to refresh or join back the session. Probably your Twitch stream got stuck somehow, but yes, I am outside. Please refresh. Thanks, Alex. So let's move forward. Now, we are going to talk about a service called Amazon Simple Storage Service. We call it S3, Simple Storage Service, and it is one of the very early service which we made available for public. I guess it was launched in 2006, and recently we have celebrated 15th birthday of Amazon S3. So we will see how this service helps and why this service would be utilized. Now, my focus would be more on the why component. Why component is important as a solution architect, because you may want to use one service over the other, and then you have to provide a rationale that why A is better than B or B is not good as C. So why is important. So let's see why somebody would be interested into using Amazon S3, what kind of service it is, what it is going to provide me as a customer. Let's go ahead and focus on that. Now, S3 is a storage service, right? And in storage, we divide storage in technical terms into three categories. Those three categories of storage is block storage, file storage, and then object storage. So these are the three types of storage which we utilize: block, file, and object. So I'll explain what these are, and then I'll explain what is S3 and how it is utilized. Let's try to understand again from an analogy so you can relate the stuff in your day-to-day life. What is a block storage? Let's say you bought a piece of land, right? When you bought a piece of land, what you can do on that you can divide it as per your own convenience. So I can say, hey, on this land I am going to create garden on that green area, and in the middle I have building an open space, and then I would have a parking for my cars, whatever it is. Now, this is my idea of putting my own way. Somebody would come and say, no, garden won't work for me. I want a swimming pool there. Go ahead, deploy a swimming pool, use a swimming pool there. Open space, no, I want to create a garden in that open space. So go ahead, do that. So the piece of land is yours. You are the legal owner of that. And there you can perform some customization as per your need. Now, when I say customization, it doesn't mean that you can break the laws. Let me give an example. Let's say I bought a piece of land in a residential area. Now, I can't say that in residential area, I am going to open a pub or I am going to open a casino. No, that is a commercial activity, and for that, you have to go into a commercial location and run your activity from there. So, legally, whatever is allowed in that legal boundary, I can divide my piece of land into different usage and keep on utilizing it. So, that's what is a block storage. Block storage, easiest example is your local hard disk. When you have your local hard disk on laptop, if you want, you can partition it, you can format it, and you can install different operating systems on top of it. It is purely your hard disk and you decide how you want to use it. That is a block storage. A storage which I can partition, which I can format, I would call that as a block storage. Then what is a file storage? Think, yes, it is Vishal, is exactly, it's a SAN storage. I won't put SAN always because SAN can give you a different storage. SAN is a network, and on that you may have block storage running, you may have NFS storage also running on that. So SAN is exactly, yes, it is good one, but not always the same, right? And NTFS is a file system J, which you would create on this block storage, or you have ext2, or you have hdfs file system on that. It's purely up to you. Now, coming to this file storage example, let's say you are into an apartment. So if you're in an apartment, then you are given a fixed area. Now you can make some modifications in this apartment. Nobody would stop you. You can say, hey, this is my apartment. I don't like color of the wall, so I'm going to change the color of the walls. No problem. Go ahead, do that. Nobody's stopping you. You would say, hey, I don't like this carpet. I want to change the carpet. Go ahead, do that. I don't want to keep closet here. I want to shift closet here in the storage area, and storage is where I would be putting closet. No problem. I want to change the bathtub into bathroom. No problem. Allowed. But you can't say that, hey, I am going to break this wall and create a door there. No, it won't be allowed. It would be interfering with someone else in your neighbor side. So we don't want that to allow. So that is not allowed. You can't say I would close this door permanently and make a door from here. No, it's not allowed. So there is a storage which is yours, but you are allowed to use that storage, but cannot perform things like formatting or partitioning. That is an apartment. Right. Keep that example at back of your mind. We will relate it to technical terms in a minute. EFS, FSX, exactly. These are all your file storage. We'll talk more on that, Vivek. Object storage. Now, if I give you my example, like I was working in Dubai for a long time, and then what I did, I moved from Dubai to London. So from DXB, I moved to London Heathrow. Now, when I moved, I had lot of stuff which I wanted to bring with me to London, but I didn't had a place. I didn't finalize where I am going to stay into London. So what I did, I packaged all my stuff into these type of boxes and rented a unit like this in Dubai. This unit is storage unit. This has a lock and key, and I would be storing my data inside it. I would be putting my stuff into the boxes. I have the lock and key mechanism on that, but this unit is only designed to store stuff. It is not designed for humans to live. It is not designed for light. It is not having maybe cooling or power. It is just a storage place where I can keep my stuff. And I kept that stuff for, I think, around 2 months. Once I settled in London, I asked the courier company to get all the stuff and bring it back to me in London. So they couriered me back into London. So what I did here, I paid for only 2 months of storage capacity here. And if I had less stuff, I could only pay for the per box, not even the whole unit. So if I'm not looking for whole unit, I can say I am going to use only a box. I would put my stuff and you charge me only for that box, nothing beyond it. So that is an example of an object storage purely designed to put your stuff, nothing else. That is an object storage. Let me explain a little bit more on the technical terms, how these things actually work. So when I'm talking about block storage, my unit of transaction is block. This would be your hard disk, right? This is your hard disk. On this hard disk, you would have an operating system running, Windows, Linux, whatever. And this operating system is going to format this hard disk into different block sizes depending on the Linux operating system or Windows. You may have a 4K block size or 8K block size. It is purely up to you how you want to format it. So transaction of units. So when I say, hey, I am going to store my resume on this hard disk, that resume information goes to operating system. Let's say this block is 4 KB, my resume is 20 KB. Now, obviously, my operating system will need to have 5 blocks allocated to my resume. So it will find out, let's use block 1 here, block 2 here, block 3 here, block 4 here, and block 5 here. And let's store a resume of Ashish. So that is being taken care by my block storage, which is my block unit of transaction, right? When I'm talking about file storage, things are little different. What happens in file storage? In a file storage, you are accessing things like something like the slash slash server name, slash folder name, and in that folder, you would have your folders created and you would be storing your files there. You would say, I want to create a file. I may want to update a file. I may want to delete a file. I want to share a file. So you can perform file level operation here. Your unit of transaction is file. That's what you can do here. In object storage, objects are also in a way file, but they have additional information which is called metadata. So objects have additional information with them that is called metadata, and we'll discuss what metadata is in a minute, but this is how my unit of transaction actually works, right? Second difference, examples. Laptop disk is block storage. When you are accessing something on network, that is your file storage. Windows share, like you are connecting to Z drive with your slash slash server name. So we are utilizing. And then we have object storage, which is OneDrive, Google Drive, Dropbox, where you just upload your file using HTTP, download it whenever you need. That's all you need to worry about. That's all we mean by examples of object storage. Let's go a little bit more on that. How can you update? And this is important. This is very, very important from design perspective. In block storage, if I had a resume written and in that resume I made a spelling mistake, I can go and update that spelling mistake and click button of save, and only that block would get updated, nothing else. So you can directly update the file. Same can happen in file storage also. I can open that file slash slash server slash file name and update that individual file, no problem at all on that. So that is all possible. You can use that. Now, in object storage, this is now how things work. Object storage work little differently. So you cannot object the object directly. Let me give you an example on that. Now, see, let me go back to, sorry, give me a minute. Let me go back to my previous example. Yeah, this one. Let's see. Let's assume that I have a box here, as you see, this box here in the, sorry, very back here, this box. So this box which you are seeing here, this box is what I want to, let's say, modify. I'm sure, sorry for that. My pen is not working as expected. Let me try again. So this is the box, right? Now in this box, I want to modify something. Now I do not have open space in that unit that I can modify the box. So what I have to do first, I have to get that box out. I got my box out, modified it whatever I wanted, removed, added whatever, and then I'll push it back into my storage space. That's how it works. I can't directly go and edit the box within that storage unit. I have to get it downloaded, upload it again after modification. So that's what we mean, that we are not directly modifying the object. What you have to do, you have to first go ahead and take care of things first, and then only you would be able to modify that stuff. So what you will do, you would be going and updating the object directly. Answer is no. You would be creating either a new version of the object or you will be replacing the existing version of the object. That's how we would be connecting to, right? Protocols, when I'm trying to connect through block storage, I use protocols like SCSI, Fiber Channel, Serial ATA. So if you're coming from on-prem world, you would obviously relate this stuff to SCSI, Fiber Channel, or other type of things. File storage is SMB, CIFS, NFS. These are the type of file storages. And then object storage is mostly we access using the protocol like HTTP, HTTPS, or REST or SOAP call. That's how we access the object storage. All right. Now, what are the examples in AWS? We will talk that, but here is one more additional information that is called metadata. Now, what is metadata? Metadata is a additional information which I am storing with my object. That is called my metadata. So, block storage and file storage do not support metadata. Metadata is a very unique feature which most of the object storages support. What is metadata? Consider you have a box, right? Now, on that box, you can say, hey, on this box, I would put a label, and that label will say what is inside the content of this box. So I can put a label that this one is my kitchen stuff. I can put another label on top, and that one can be say that is a fragile item. It may get break. Then I can say the weight for that is 20 kg. What I did on the outer surface of the box, I have added extra information that exactly what a metadata is. So object storages allows you to hold metadata information, which is additional information about that object. So we would be talking about what metadata is. Now, sometimes people get confused with metadata and file system attribute. Let me explain that also. Every file system maintains some information, but it is different. Let me show some details here. So let's say I am having my uh, Windows machine and I have a file here called delivery.jpg. If I select its properties and go to that property of a file, let's see what we see. So it's a JPEG file, and here are my details tab. My operating system has added these things: tags, author, date taken, image ID, dimension, width, height, and all the stuff. Right. So this is maybe if it was a picture clicked, camera information may also come with that, and that would be added by the camera. This is my JPEG file. It has different information. If I have a text file would have additional information which will be different. So this one has less information like size, folder. Now I can't add a tag here which says cost of this file or expiry date of this file. That is not we can add here. These attributes are maintained by file system. So these are yes metadata, but our object storage have a different way that you can bring your own metadata into the system if you want to. So hopefully you are clear now that what is my metadata. So metadata is supported by object storage. It is not supported by other operating systems, right? Example in AWS, block storage is EBS. Amazon Instant Store is another example of block storage. We'll talk about these two in next session when we discuss EC2. Then file storage is EFS and FSX. These are service name. And then the services are Amazon S3 and Glacier, which are called my object storage. So we'll talk about object storage now. We will focus on Amazon S3. All right. I hope everyone is doing okay and understanding and enjoying the session. Now, I think it's a good time to take a short break. So let's do one thing. If everyone is okay, let's take a quick 5-minute break. And once we come from break, we will then discuss about simple storage services. Probably you want to top up your coffee, fill up your water bottle, or have a pizza. Why not? So let's take a 5-minute break and we get started. I'll put a timer so everyone knows when to come back. Thank you. See you in 5 minutes. Welcome back, everyone. I hope everyone is back, had a quick break, and ready for another session. So let's keep on discussing what S3 is, and we will go ahead and talk more in terms of how to use this. So I'll be a little practical here, and I'll show you demos on the console. So we'll see what S3 is. S3 is a place where I store data. That data could be a file, could be a video, could be anything. I don't care. S3 doesn't look into your data. Whatever you want to dump into S3, you can. Some limitation are in file size. Maximum file size for object is called 5 terabyte. Now, The concept in S3 is first thing you create is called a bucket. So if you see this green box here, like a bucket of a water bucket, that is a bucket. Bucket is a placeholder where I would be keeping my data, and data is stored in S3 bucket in form of objects. So this triangle and the circle and the square you see, these are my objects which I'm going to store inside my S3 bucket. So bucket is what is the outer boundary, and within that you would be creating your object. So let me quickly go to console, and we would start creating a bucket, and we will then see how this bucket actually looks like. Now, one thing you have to be aware, that bucket name when you are taking, they should be unique. They should be globally unique. So currently I am into Ireland as a region. As you can see from the console, I would look here and search for S3. This is the AWS Management Console. Another good part about this console is if you are not sure like which service name is, just type what it is, storage. So if I talk storage, it would bring up all the services which has related to something with storage. Like I have S3 here, storage gateway, FSX. So I'm going ahead and talking about S3, which is scalable storage into cloud. Let me get started with S3. So first thing to get started is to create a bucket, and in that bucket then I can add my object, which is up to me how I want to keep it. Do I want a folder structure, or do I just want to dump everything on the root? It is purely up to me, but to get started you have to create something called a bucket. Let's get started by creating a bucket. So I'm in Amazon S3. Now people get confused here because as soon as you come to S3, this shows global. So does it mean S3 is a global service? I would say S3 namespace is global, but the bucket you create is contained within a region. And if you see, I have few buckets in my account. Like this is a bucket which is in US East North Virginia, another one in Frankfurt, another one into US West. These are all the buckets I have. So let's go ahead and create a bucket. I would try to create a bucket with the name test, and probably it would fail because somebody would have already created a bucket called test into EU West 1. So I have given it a name called test, and I try to create a bucket. Let's see what we get. Bucket with the same name already exists, so the name should be globally unique. So let's go ahead and do this like BeSA, and what is today, 14th May 2022. Probably nobody would have created a bucket like this. And let me make another one here like Ireland, so I can know that this bucket is created into Ireland. So I am selecting a region in Ireland. I want to create a bucket. There are other settings also. We'll talk about them. There is a setting called block all public access. I would keep it. I will talk about it. But idea is then I would create a bucket. Once a bucket is ready, it is a placeholder. In that bucket, I would then start looking for or updating my object or keeping my object. So let me search for that bucket because you may have a lot of, and here is my bucket. A bucket and objects are not public, creation date. And in this, now I have a way to upload my object. So I can go here and say, okay, I want to do what? I want to upload my object. So I would go ahead and say upload. Now I'm doing it just to show you manually by clicking and uploading one object. But in real life, probably what you would be looking for, you would be looking for adding objects from command line or some other ways. So it would be faster. But if you want, you can first create a folder and add folders or add file. It is purely up to you what you want to keep inside. Select a local file which you are looking for to update. And from that, you should be able to pick up your data. So let's say I select something from desktop. Probably there is something like invite.ics file. This file is of 816 byte. I have a destination. This is my bucket naming format, S3 colon bucket name. More details on destination, I'll talk about them. And I say upload, and now my object has been stored into S3. See this, one file has been uploaded. What I did here, I have used my bucket to hold one file, but if I'm looking to create folder structure, that is also possible. Within this bucket, I can create a folder called images, another folder called PDF. It is purely up to you how you want to use it. So this is my bucket, and I have an object inside, as we can see. If you are looking to create a folder, and I want to create a folder and say my object will be stored inside a folder called data. So we can, or data 123, I can go ahead and create a folder. Now this folder is just for bifurcation. Actually, S3 doesn't have a folder structure. S3 keeps everything into a flat file and or in a flat structure. what is going to happen if I upload something into this data folder now? Let's say I go to this data folder and I say I am going to upload something here. Let's add another file and see how the naming convention would be changing. So I select again, and probably let's select, like say, eBay return, not the good one, CSV to Parquet. This is the file, CSV to Parquet, 3.3 KB. I am putting it where? Into data folder, and I say upload. Every object you upload is having a name associated with it. As we see, this is all having a name associated, CSV to Parquet. Now, in technical term, this name is called key, Key. The name is called a key. Now, key is a representation of that object which we have stored on that. So one object, if you have, that object's name was what? Let me write down on a notepad so you can relate to it. So first object I stored was invite.ics. So in that case, the name of that object, what we call key, was just invite.ics. Just give an example. Right. Second object I uploaded, it is stored into a data123 folder. So its name is slash data123 slash csv to parquet dot csv file, whatever it is. So for me, it looks like it's a folder structure, but for S3, it is a flat structure. If in that folder I again add another file, that would look to me like a file, but that would be again a object in S3, which is with this particular name. So this is how my S3 stores object. For you and me, it would look like a flat structure, but it is, sorry, a folder structure, but it is a flat structure. And this whole thing is called the object name. As we can see here, this is what my object name is. And every object gets a unique URL associated with it. See this. So the object which I uploaded, which is object URL CSV to Parquet and into this got a unique URL associated. If I'm trying to copy this object URL, trying to open it, obviously I would get access denied, because by default no object is made public. More, if you don't want that to public, it is by default private. You would make attempt to make it public, otherwise it is all private. And as you can see, I am getting access denied here. So every object would have a unique URL associated with it. Whatever I have uploaded, everything has a unique URL associated with, whether it was a folder, whether it was an object, everything is here. See this invite.ics. If I go inside this, I would find that this one also got a unique URL like this, right? All right, now what I can do here, I can go ahead and use some command line to upload more objects instead of manually doing things one by one. If I'm looking to put a lot of data in that kind of cases, I would go to S3 command, or means my AWS command line, and from there I can perform some operations. So I'm here. Let's clear this out. I go to maybe temp directory, I guess so. Not the one. Temp test. Let me check. CD, what is the directory name? Temp. So I go to temp directory, and there I have some directories, and I have a directory called static website. Let me go there. So I say cd static website, and I can see there is a folder structure. There are dir, which is css file, font file, images, index.html. What I'm looking for, I'm looking to copy all of this into my S3 bucket, which I created. All right, let's go ahead and do that. So what I will be doing here, I would be saying AWS, this is invoking AWS command, which namespace S3. What you want to do? I want to copy CP. You don't have to remember, these all helps are available into command line. You can put help and you would get that page. So I want to copy what? Dot everything. Where? Source is dot, means everything within this folder structure called static website. Where I want to copy it, I want to copy it to S3 colon the website we created, sorry, folder we created, bucket we created called BeSA 14th May 2022 and Ireland. Let me quickly check the name that I am putting the right name, and we will then copy it. So BeSA 14th May 2022 Ireland is my bucket name, and I want to copy all my object from this location to it and into recursive format. What this will do, It would maintain and create the whole folder structure into S3. I initiated the command. It would copy everything from my local machine in this directory to that particular S3 bucket, which we are seeing into the folder structure. So let it give it some time. And as you can see, the files are being copied to me. I could manually upload them one by one, or better to use command line because it's a huge amount of files I'm transferring. Manually doing it will create a lot of problem. I'm done. My work is finished. As you can see, my files have been uploaded here. These are all HTML files, CSS file, and other stuff around it. Let me make it a little smaller so you can see. This is my bucket, and in this bucket now I have about.html, cart, invite, lots and lots of stuff here. But are these bucket content right now public? Answer is no. By default, bucket is private. I can't access any of the content right now. Nobody can access it. What I need to do if I want, and I'm saying it is just I am doing it for demo purpose. In real life, people or customer would not be making a bucket public. I'm just trying to show you a demo around it. Right. If you want, you can make one single object public, or if you want, you can make the whole bucket public, and for that you need to configure its a permission. So we'll see that association. We have option for permissions here. I am selecting the bucket, and in that I am going to personalize. Now here it says access bucket and objects are not public. That's expected. Let me go ahead and change this setting first. So this is my permission. I say by default it says block public access. I am going to override it. I would say I want to add it, and I want to remove this setting. Now removing this setting doesn't make it public. Removing this setting already just says that we are having a potential to make these objects public, but they are not by default public. I will maybe in future I would be allowing them to be publicly accessed. I want to make them ready to be available, but right now still they are not available. I unchecked it. It says I am having a potential to make them public, but still I haven't made them public. I say confirm, and now my object have a potential to be public, but still not public. So how to make objects public after this setting? You can make that individual object public, or you can configure here something called a bucket policy. And this bucket policy would apply to the component within the bucket, by which you can control either all the object or a portion of the object. It is purely up to you. So we can use here something called a bucket policy. Let me get started with the bucket policy. I will add it and we'll get started. Right. Now, what is written here is a language called JSON, right? JSON is a very common way of representing things in AWS. This is having a structure. It is basically a key value pair. This is what I am seeing here. So this is my JSON file. I can use this for policy, or if I'm looking to create my policy automatically, I have an option here for policy generator, and I'll show you some resource link today where you can find more different policies available. So I am now into a policy generator, and let's see what we can do here. In this policy generator, I am interested to create a bucket policy, right? So this is my S3 bucket policy. What I'm looking for, am I looking to allow or deny something? I am saying I am going to allow something. So let's go ahead and allow. Principal. Principal is basically saying who. Is it be Ashish? It would be Alex, Jamila, Chris, or James? Who would be allowed to this? Or would it be allowed to everyone? So I would say star. Star represents everyone. So when I say star means I am making it publicly accessible. All right. Now with service S3 that is expected action on that object, who can do what? So I'm saying everyone can do what kind of actions they can perform, and we have lot of actions to choose from. These are individual permissions which I can assign to an individual user. Like there is a permission called put object. So they would be able to store their object here. I can put another permission here, which can be for delete object. So they would be able to delete the objects from here. Or I can put a permission, very simple one, which is called get object. Get is basically a read. So I'm giving a get object permission, which is allowing them to read my data. So I'm giving a get object permission to them as we have selected. Now, next thing it says Amazon resource name. This is important. Every object you create in AWS, whether it is a bucket, whether it's a EC2 machine, whether it's a Lambda function, whatever it is, they all get a unique name. That name is called ARN, Amazon Resource Name. So let me go ahead and talk about that name here. So if I go to my bucket here, my bucket name is this, but the ARN is like this. See this? ARN AWS S3 BeSA something something. So I copy this, and this information I can put into my policy generator. I am pasting it here, and now I would say, okay, I'm happy. Let's add a statement. So what happens now that I get a object ready for me, a policy being generated for me. I would now say generate policy, and it would create the JSON document for me. So this is having some information like ID of the policy, version number. Now this version number is not of the policy, it is the version of the JSON. Java State Object Notification Language. That version is 2012. So don't get confused. This is not the policy creation date. It is a JSON version. It has a statement ID. We don't need to worry about all these things. This is important. What I am allowing, get object. To whom, what I'm doing, allow or deny, I am saying allow. Principal says to whom. If I put person's name here, only that person would be allowed. But here I have put star, means I am making it public. And to whom, which resource. So this is my resource name. So if you read this, I am saying I am going to allow reading to everyone for this particular bucket. This action applies on object. I can copy this whole thing, copy, and I can then paste this thing into my bucket policy example here, right? I can go ahead and say paste. Now I have a bucket policy which is allowing get object permission for me. Are we clear here? Anyone, any questions, any doubts, any confusions, anything which is not understood? So hopefully everyone is clear and understanding the topic and understanding how we are doing it. So what we can now do, I can click on save. But I am giving you a warning here. As soon as I would click save, I would get an error. I'll explain that error in a minute. See this. I click save and there is an error coming up which says action does not apply to any resource in statement. Not the best not the best error message, but what it is trying to do, it is saying that, hey, which action I am allowing? I am allowing action called get object. But here the resource I have given is the whole bucket. So bucket is not an object. Bucket is a bucket, right? So what I'm looking for, we are looking for allowing access to slash images slash star dot png. What would happen now? Which means in this bucket, every object which is into images folder, which has an extension of PNG, that I am going to allow. So we have to put a star here, or at least identify which specific object. If you want to make one object public, say file1.png, that's all. We do not need to worry about it all. So here I have to be very specific what I am going to allow. Now to make things easier for everyone, what I'm doing here, I am just replacing this whole stuff with star. Star is a wildcard. This is basically making every object within that bucket public. And now once I'm happy with this, I can now save changes and I would have my bucket straight away become public. And now I would start getting a message here at the top. Hey, red warning sign, this bucket is publicly accessible. Which means anything which was not working for me before, see this access denied. See what happens, right? What we are seeing here, we are trying to perform action on it, and see this. Now my CSV to Parquet file is have ability to download, which means I am basically able to download it. Let's verify some more stuff here. What I have in this particular bucket, I have lots of pictures. Now today is a food day, so a coffee day, I would say. In a way, I'm not talking in the actual day perspective. The examples I'm taking are from that. So if you remember, the bucket name which we had was this BeSA, and in that I have some stuff. I have some stuff which is HTML file. There are some font, there are some images. So let's go ahead and check images inside. In this images folder, we again have stuff related to burgers, dessert, dish, and then drinks, and then gallery and menu. So let's go ahead and see after pizza, why not a dessert? So let's try that dessert. So this is my dessert1.jpg file. obviously it has an object URL, and now as this is public, if I go, I can paste this URL here, and I should be getting a whole object delivered to me. So it looks like a nice desert which we can have, right? So what I did, I made the whole bucket public. But what if I want to perform some additional step? A common thing which customers use S3 for is to host a static website. Now S3 is just a storage. It cannot run your Java code or it cannot run your PHP code. It can deliver content to your browser. And if you are using some languages like JavaScript, which are compiled and run on the browser side or which executes on the browser side, you can use those JavaScript to run and display the whole content as a website to my users. That is possible. So if I see this BeSA structure, in that what I have kept some HTML file, some CSS file, some images, and then some ICS file which we uploaded JavaScript. So these is basically a folder structure for a coffee company website. Let's go ahead and deploy the coffee company website from here. Main page of that coffee company website is in index.html. So what I'll do now, I would ensure that if a request comes to my application, I would get a URL, and that URL points to this index.html file. So let me go ahead and put this information there. So I'll go to its properties. I am leveraging a feature of S3, which is called making it a static website. So I'm using S3 bucket. I am going to its properties, and here at the very bottom, there is an option which says static web hosting. Do I want it? I would say yes. I want it, and I would say edit. And in this case, it will ask me some question. Are you okay to enable it? Yes, I am okay to enable it. Thanks for asking. Now, I want to host a static website. I could redirect it to somewhere else also. So I'm Zeb, I would open it. I'll obviously invite you. So I have index.html file here. And now I say, what is my index file? So my file name is same index.html. I would put it there. And maybe if I have an error page, I would be opening up and say, hey, error.html, which I am putting it here. Right. If I have any redirection, I could put it. I'm keeping it as simple as possible. So my request will be forwarded to index.html. I save it. Now S3 would be giving me a unique URL to represent my website. And that URL is visible here. Give it a few seconds and see this URL. This is now not directly referring to index.html. It looks like a very formal website, not very friendly name, but I can take it to a DNS server, and from there, I would be able to make it a friendly name like mycoffeeshop.com and take it from there. So I copy this URL, and let's open it into a browser and see what the result looks like. I'm opening it into a browser, and what I will find here, I would find a different website running it, and looks very professional website. Home page, menu items are there, then there are services we offer, there is a blog post, there is a about page, and there are some links like there is a shopping cart, the menu items are there if you want to book a table. Now this one is purely going ahead with what, this is just a static content, and this is being delivered into my website. Right. So what I'm doing here, I am able to get all the stuff here and get it ready. Okay. Okay. Good. Subhash had a question. I lost question. Subhash, it is somewhere up in the chain, so I can't. But maybe in the later, if you have any question, we'll have maybe some time. I would be able to show you some information there. Right. So hopefully everyone is okay now that what I did, I hosted a static website from my S3 bucket. Now it is not actually doing booking or doing processing of my order, but what I'm doing here, I can access this. Right. Right. So this is my access website, which I have hosted, and I can utilize this, should not be a problem. Okay. So that is one feature which I talked about. Let me talk about some more features. So we talked about S3 namespace. Bucket is a regional entity. Now you would find a lot of time people talk about durability in S3, which is called 11.9. And then they talk about availability, which is 99.9x%, 9599, depends on different tiers in S3. Let me quickly explain what a durability is and why somebody would be interested into a concept of durability. Now, durability, if I have to write it down, I would say durability is basically a retention mechanism. Let me give an example. Let's say this is your office. a big building. You forgot your laptop here, right? And this building operates or runs from morning 7 a.m. up to 9 p.m. in the night. Only till that time people are allowed to access it. Afterward, you can't access it. So you went with your friend to a pub, you got late, you came back, office was closed. Your laptop is still inside. Now, office is closed. That's why I can't enter inside office. But it doesn't mean that my laptop got stolen. Laptop is still there. When early morning office would open, I would be able to go and get my laptop. So my laptop is durably stored within my office building. It is durability. So if I store a data in S3, that is giving me this much of durability. How? For you and me, I updated an object called object1. What S3 did at the back end, S3 copied that object to three different physical location or three different places, but within that region where the bucket is. So within that region, Ireland, S3 have copied my object to three location, ensuring that even if one of the copy get failed, hard disk get failed, we would still be able to get my object. So that is called durability. And durability here is 99.999. That means that if I store 10 million object, maybe over a period of 10,000 years, one object may be lost. What is the probability? Very, very less. But there is a probability of object getting lost, but huge less probability. That is what we mean by a durability. So durability is a mechanism that what is related to retention, that will my data be stored in safe way or not, that is called durability. Right. So durability, hopefully everyone is clear. Let me now focus and talk about availability. What is availability? Availability, I would say, can I access my data right now or not? Let's say you stored your data into an S3 bucket. Now, due to some reason, there is a network outage. So you can't access S3 right now. But that doesn't mean that my data somebody deleted. My data is still there. When I would have network established, I would be able to access my data again. My data is not lost. Data is still there. Maybe right now I can't access it, like in my building, operates from 7 to 9. So my data is still there, laptop is still there, but I can't access it right now. So that we mean by accessibility. Sorry, availability. So availability is 99.9x%, whereas durability is this much. Hopefully everyone is clear. Maximum object size we store is 5 terabyte. Maximum we will store will be 5 terabyte, and we can do what? We can also host a static website on that. So static websites can be hosted, should not be a problem at all on that, like I have shown you an example. So that comes idea. Hopefully everyone got the idea. Let me now focus on pricing. Now, I'll give you here a golden rule that most of the AWS service pricing revolve around the thing I am going to discuss now. What are the common things we charge you for? Now, it is pay as you go model. So in most AWS services, you will be paying for compute, you will be paying for storage, and you will be paying for network, plus some additional stuff. This is a common way. So compute, how in S3 your compute is calculated. So first thing in S3, you would be paying per GB. How much data you are storing, that much per GB cost you would be storing. So bucket can have 5 TB or a single object can be 5 TB. So hurry, bucket can have hundreds of 5 TB objects. Maximum object size for one single object is 5 TB, terabyte. But you may have hundreds of 5 terabyte object, no problem at all on that. Right. So storage is per GB as we see. How much you pay for compute? So compute is calculated based on number of requests. So when somebody is doing a get, when somebody is doing delete, when somebody is doing a put, these all are considered as a request which is coming up to Amazon S3. So Amazon S3 will calculate these numbers of requests and charge you for that. Network, we charge you for data transfer out from S3. Somebody downloads my file. So that would count one request for download, and the file was 10 GB. So that 10 GB will be counted as my data transfer out. So these are the three major factors we consider for every service compute. In terms of S3, it is number of requests. S3 storage per GB, and the network is how much data transfer out I am having. That is up to you what we want to store. So this is how my pricing would work. So these three things. Additional stuff we will talk about, like you are doing versioning and all the stuff that would cost money. So compute, storage, and network. Hopefully everyone is clear about that. Okay. Now it has lots of other features. Now I don't have time to cover everything. S3 is there from last 15 years, and I can't talk about 15-year or of innovation in just 90 minutes. So I will send you some detail where you can talk about versioning, replication, and transfer acceleration. Lots of interesting stuff can be done on S3. It is not a dumb storage. It's a very smart storage. It depends on the user how well they want to use it. Right. Let me now talk about something called S3 storage tier. I would take another analogy to explain things to you. We all, maybe some of you may have visited London, and in London, we have something called different transport zones. Right? This is what they call underground tube map, but I'll show you a very better example from a Google map so you can relate what I'm talking about. So London is divided into different transport zone, and you are charged from one transport zone to another transport zone. So this is how the things are. This is called zone 1, the London where it is written. This one is where lots of tourist attractions are. Covent Garden, Mayfair, Paddington, you want to go to see Westminster, or you are going to go to London Eye. All of these things are on this area, which is called my zone number 1. So zone 1 is where all the tourist attractions are. And then all other places, there are other things which you can go for. So we'll talk about how these things. Let me give an example and I'll talk about how this relates to S3. Now, let's say I am visiting London for 10 days. 10 days as tourist. Now, I may want to obviously visit central London as we call it. And I may want to visit other places outside. Let's say I want to then go to Cardiff, maybe I want to go to Manchester, or I want to go to Leeds, maybe I want to go from there, let's say, to Cambridge to visit some universities and all. So this is my plan. I want to visit for 5 days. May want to visit central London, and for remaining 5 days I would be going to outside of London. Right. Obviously, when I'm visiting London as a tourist, I would need a hotel, right? So let's try to understand that concept, that how I would be taking care of the things. Let me show an example. Now, let's say this is central London. Now, these are different zones: zone 1, zone 2, zone 3, and zone 4. London transport is divided like this. And as I told you that most of the tourist attraction are into central London, this is called zone 1. So if I'm visiting these tourist places, I have to worry about two costs: hotel cost, right? And I have to worry about the transport cost. Let me explain that. Hotel cost is when I stay. Obviously, when this is a tourist place, hotel cost into central London or zone 1 would be much higher, isn't it? Why? Because that one is very popular, and we would be paying a lot of money, not three figures, but maybe a good amount of money I would be paying to stay into hotel into zone 1. But advantage is, if I'm in zone 1, probably I can just walk or just use underground and only be in zone 1, so my transport cost would be much lesser. So I would prefer that when I have to go to central London every day and visit the places, maybe for 5 days, let me stay into zone 1 so that I save on transport cost. I am paying more on hotel, but I am saving on transport cost. Right. Next one. If after 5 days I have to go outside of London, which means I don't have to come to zone 1 anymore. I would be taking trains or buses or maybe something else from outside of the London. So what is the point to stay in zone 1? Let me store, let's say, into zone 6, which means I would be paying less money for hotel. And if requirement comes that I have to come to central London to catch air taxi or something, or maybe just one place I could not enter, I have to come. For that particular moment I will come, I would pay more cost for transport in that case. Hope you're getting the idea. So these are two different use cases. Visiting central London is a use case. Going outside of London is a use case. So In some cases, it would make sense to stay into central London because you would be able to store transport cost. In some cases, it would make sense to stay into zone 6 because you would be saving the hotel cost. Now, how all these relate to AWS, let me try to explain this thing. What I'm going to do you to show, I would be showing an example of how all these things work together. Go, give me a minute. I'll talk about how these things work. Now, in S3, when I was uploading an object, let me try to upload an object again. I have option to select different storage classes. I would again click on upload button. And on this upload button, let's say I am trying to upload an individual file. In previously, I haven't shown you that example, but let's say now this is a Kindle Create icon, which I want to upload. This is 74. This is big. Let's not upload it. Okay, let me just show that. Now, here in the properties, you have something called storage class. And these are different storage classes which S3 offers: standard, intelligent tiering, standard infrequent access, one zone, glacier, and all. These are different classes. And see this. This one is designed for frequently accessed data, more than once a month access with millisecond access. So you would get your data much faster, but this will charge you higher. Availability zone, it will be copied into 3. Then we have one zone. Let's talk about something called standard IA. It says infrequent access. Infrequent access data once with millisecond access, but maybe you plan to access this data once a month. Better is to keep it into standard IA. Let me show the difference between prices. I would be quickly going through simple monthly calculator, and I would show you from there. AWS simple monthly calculator. There is different prices associated with different tiers or storage classes of S3. I am going to show you that example, right? This is my simple monthly calculator. Let's go ahead and see some details around it, how it actually works for me. Let it render. Now I'm running a little bit out of time. Alex and Jamila, for your session, probably we would extend it if everybody is okay. Let's see. Let me just explain this and I'll hand it over to you then. So now I am going into Amazon S3 here. Hope you remember this tool from last discussion. So I'm in S3 and I am storing, let's say, in standard storage, 10,000 GB of data. And I am expecting that requests coming to that put copy and paste would be 100,000. Just give an example here, right? So what I did, I have put some numbers here that I would be storing 10,000 GB of data into S3 standard, and these many requests would come for access. Okay, let's see the difference here. Now the price. I'm checking the price here. How much I would pay for? I would pay for $230.50. Let's explain that. I would be paying for S3 storage, which will be $230, right? This much I would be paying for storage cost, and then 0.50 I would be paying for the put cost. Let's see, we see standard put request is what I would be paying for. Let me put it on a notepad so we can relate this stuff in a different tier in a minute. Give me a minute. I'll bring the notepad and we will store it there. So this is my S3 standard. My cost is $230, and how much I am paying for access? I am paying 0.50. This was get request, sorry, put request. Let me do a get here instead of this get. So get is this many requests, and obviously I can see now my cost is different, 230, and I am paying for 0.004 here. So let me note down this number. I would keep the same data, but I would change its tier. Let me reset this form, and I would change its tier to a different tier called standard infrequent tier. So this is my standard infrequent access tier. Same 10,000 GB data, but I would be having the similar request of 100,000. And let's see the price now. See the price? Price is 125.10. What happened here? Let's see. In this case, I am paying 125 for the storage cost. Hope you are getting the idea. And I am paying 0.10 for the access cost. You get the difference? I am paying less for storage, but I am paying more for access. This is what type of storage tier I have used. I have used this S3 infrequent access. Right? Let's reset it and let's talk about one more tier, which is called Glacier. So what I'm going to do now, I am resetting it, and now I am going to S3 Glacier. I would be storing the same 10,000 GB data here, but I would be having retrieval of the number of requests. If you see here, retrieval request is same 100,000. Let's see what is the difference now. Let's see the pricing. Cost is $41 only. What is the difference here? My cost for storage has come much lower, as you can see, but my storage excess cost has become higher. So what I'm trying to explain you here, that if you feel that your data is going to be used again and again very frequently, better to keep it into here. If you store your data and it is not going to be accessed frequently, put it into infrequent access tier. And if you want to store it for a very long period, better would be to put it into Glacier. So we give you mechanism to put your data into the tier of your choice, whether it is a standard, whether it is infrequent access, whether it is Glacier, and you can move this data automatically. Let me give you a simple example on that. Let's say you have a HR application. There is an open position in your company. HR has a mandate that in 30 days this position has to be filled up. So HR, he or she would be calling a lot of people to submit their resumes. Lot of people would send. Let's say we got 200 resumes. Just give an example. So for 30 days, HR would be frantically working on these resumes, scheduling interview, calling these people, and we would need them. But after 30 days, let's say position is filled, we don't want to delete it. For initially, I would keep it into S3 standard tier. But after 30 days, I would say, all right, I don't want to use them frequently. I want to save money in storage. So let me now move this to infrequent access for after 30 days, and I can automate it. Afterwards, I would be keeping this data. Let's say mandate is that you have to keep this data for at least 1 year, whoever submitted the resume in the system. And after 1 year, I can say I would put it into Glacier, which is much cheaper in terms of cost, but I'm not accessing it again and again. And then I can say afterwards, after 2 years, I would be completely deleting that. I do not need it. So idea is that it is up to you where you want to keep your data, and that's how we are able to save a lot of money, right? So it's a good way to store your data. Lots and lots of options are available into S3, and by which you are able to store data and keep it. So say in city center, you pay more hotel, less for taxi. You move away, you pay less for hotel, but you pay more for taxi if you are coming back to city center. So hopefully everyone is aware now what can be done, and these things can be automated as we see. So we can go through S3 standard, move to infrequent access, then from there move to Glacier, then expire that data, and similar stuff can be done by something called intelligent tiering. So I will send you some more examples today which you can get hold of and read more on S3. So S3 is a nice service, very specific use cases, lots of things can be achieved from it. And if I given time, I could talk whole day on S3, but we have limited time, every one of us. So let's now hear from solution architect that how they would be utilizing S3, or what are the customer use cases for S3. Okay, so I would be uh, asking Jamila to help us. Jamila would walk us through use case of Amazon S3. I'll add you to stage. Give me a minute, Jamila, and I will be giving you permission. I will be sharing the details with you. Give me a minute, please. I'm trying to figure out where the button are to click. Yes, I added to the stream, and hopefully you can see me. Hello. So Jamila, can you introduce yourself a little bit and then please explain us about S3?
Cool. I hope you're able to hear me. Yep.
Yes.
Cool. Cool. Hi everyone. Good morning for those who are based in London or Europe. Um, I'm Jamila. I'm a solutions architect at AWS, and I'm here to talk about how you can use Amazon S3, which is our storage service, to utilize in IoT use cases. So one of our customers wanted to monitor the building occupancy and see with using IoT devices and stream it live to AWS, store the data, and perform some analytics on that. So um, I, I I built a solution I designed the diagram, etc., and then I decided to publish it for wider use case. While the real customer use case was they wanted to see the prototype how it looks like on AWS. Um, in the real life, in production environment, they had their own IoT devices. So in the blog post that I'm going to share with you all, I'm using Raspberry Pi, which is a small board computer, and a passive infrared sensor which detects the motion. And then after that, all the data generated with Raspberry Pi, it will be sent to AWS. I'm using some AWS IoT services that I'm not going to discuss in depth today, but just as a high overview, one of our AWS IoT service, which is called IoT Core, connects the Raspberry Pi and the passive infrared sensor with AWS Cloud, so that once the data is generated live, you can stream it to the cloud in real time, and then you can store it in Amazon S3. So I'm going to share the link in the chat. And if one of my colleagues please can
Yeah, I'll do
share
that.
the screen. Yeah, thank you. That will be great because I
So
am having
this
some
is the
technical.
link, and let me open it into, give me a minute, please. Jamila, there is a chat window. If you could send me there, because I am seeing it in the private chat. If you can send, I would be able to copy the link. I
Okay.
cannot directly copy
Yes.
from
Yes.
this
I
place.
just did it.
Yeah, I got it now. I'll
Yeah.
open it for you, and you can
Thank you.
walk us through that. Give me
Cool.
a minute. So everyone, this is a use case for a customer. It's a prototype we are talking about here, but obviously customer can implement it in a different manner. So let me quickly make the screen available and we will get started from there. Good, give me one more minute and
Thank you.
hopefully everyone can see this blog post. Yeah,
Yeah. Cool. So if you scroll down, please.
sure.
You will be able to see the simple diagram that I architected when I joined AWS. It was like around last year. So you see the Raspberry Pi on the left, which is generating some data in real time, and then some other services, including AWS IoT services, IoT Core, IoT rule, where you set your rule that once you get any data from Raspberry Pi, send it to Amazon S3, which is in the middle. You see Amazon Kinesis Data Firehose, which is our real-time data streaming service. And then all the data, once it's been captured from Raspberry Pi, it will be sent and stored in Amazon S3. You will see other services like AWS Glue and Athena. I'm not going to talk about it, but rather I'm preferring to highlight Amazon S3's capabilities, that the data has been generated from Raspberry Pi. It was stored in S3, and this gives the customers a capability to perform data analytics using S3 in itself. So in Amazon S3, we had you will see lots of kind of objects and the data points that is coming from Raspberry Pi. Yeah, if you scroll down, you see how the Raspberry Pi was set. You see all the details. You will get a code snippet. What it is, what kind of data it is generating, like motion is detected or no motion, and then when the motion is detected, the red LED light will be turned on. And here is you will be able to see the IoT role that we set for IoT Core, and then everything will be stored in Amazon S3. So the important part is that Amazon S3, as a storage service, it doesn't limit you what kind of data you can store. So you can store from across different resources, including IoT or other resources, or if you have any third-party connector, you can still connect the third-party connector with S3 and stream your data or bring your data from different resources and store it in Amazon S3. Other good point is that you can archive it, as Ashish mentioned earlier. You can archive your data. For example, you don't need a building occupancy data back in like 5 years ago. You will need it, for example, only for your once a year report. So you can archive it and save some cost on archival point as well. So the main point is that instead of creating relational or non-relational database, you can easily and in a cost-effective manner, you can store all this data in Amazon S3. And then if you scroll down, Ashish, I just want to show Amazon QuickSight part, which is our data visualization BI tool. There you will see that the data which is stored in Amazon S3, you can easily connect with either Amazon QuickSight or any other third-party providers, independent softwares, and then you can perform analysis. For example, how many people were in this part of the building, and what is the data point. So you can drive the reports, you can make analysis based on this data. So this was the high overview of usage of Amazon S3 in IoT. Of course, we have many more resources, but it is just one of many. If you have any questions, please do let me know. And here I will stop talking and I will hand over to Ashish. Thank you.
Nice. It's an interesting use case. Like a Raspberry Pi is a nice way to get started, and then if you can bring that data to AWS, then possibilities are unlimited. I maybe when we get time, I'll show you one flight radar I built using Raspberry Pi. Like Jamila here has built a IoT core. I have used it for building uh, flight radar, live flight tracking, and again using S3 because S3 is a ubiquitous storage, very cheap comparatively, accessible over HTTP. You do not need any servers, and it's a much easier to get started. So maybe you don't want to implement the whole stuff as it is, but I would suggest that read it. Like, what are the possibilities to use S3 for? What can be achieved? What are the challenges we have faced, and how we solved it? And another part is integration, because as a solution architect you won't be working only with one individual service. You would be working with multiple services and they have to all connect together. So that is what is important for you to learn as a solution architect. So thanks Jamila for walking us through this. We would push this link into our resources page, so feel free to check it and let us know if you have any follow-up question. We'll try to answer as much as we can, but yes, we are still human, families to maintain, job to do, but we'll try our best to reach out to every one of you. Thank you, Jamila.
Thank you, Ashish. Thank you, everyone. It was a pleasure.
Same here. Thank you. Now, Alex is also going to walk us through some of the stuff related to uh, how customers use S3. This was one use case, but as I said, S3 is present everywhere, I would say. Anything you do, it has some footprint on S3, and Alex would help us today to make sure that how other customers are using. And these are some big names of the customer you would now hear from Alex. Thanks, Alex. Over to you.
Yeah, thanks. Thanks, Ash. I'm not sure if you
Alex,
shared
can
this on
you?
my screen.
Yeah, I can share your slide deck. Can you can you talk about yourself, because some of the people are new today, so I
Oh,
may
yeah,
want
absolutely.
they want know about you.
Yeah, no worries. Yeah, absolutely. So that's one of
Thank you.
the most favorite exercises, talk about myself. So, so I'm Alex. I worked as solutions architect at AWS with some of the folks on the call in the same team. So covered like large customers, helping them out with their cloud migrations, cloud journey, and helping them upskilling and things like that. All right.
Good.
So,
So Alex, you want to share screen
yeah,
or should I share screen for you?
I think I have, in the StreamYard,
Yeah,
I
I'll do
think
that.
I'm still
Yeah,
sharing.
got
Yeah,
your point. Yeah, I'll show that.
yeah.
Give me a minute.
All right. So what I'm going to do in this slots here now, we talked about S3, and this is one of the most fundamental services. It's very hard, to go around and not to use S3 when you're designing the architecture on AWS. And here I'm just kind of picked up three big names from the industry, who, of course, use S3 behind the scene. You probably know all of them, and this is not the only examples of our customers who use S3. S3, as I said, can be found almost in any architecture. And so those three big guys here on the screen, what they do. So let's start with Coursera. Probably everyone knows Coursera, right? So Coursera is basically a company who provides online trainings, courses from different universities from all around the globe. And what they do with S3, they basically use S3 for hosting their website. So this use case we talked about, like S3 for hosting static content, they actually do that. The other example here is Airbnb, and those guys, what they do, they use S3 to store and serve their static assets. Like they particularly use it for storing 10 terabytes of user pictures. So those pictures you might see on the postings of different houses. So this is what they use it for. And then Netflix, of course, Netflix uses it for managing their storage, media storage infrastructure, and asset management. So they also use S3 for it. And we talked a little bit about, that S3 is not only about, S3 is not only about media companies and not only about streaming some particular media content. It can be found all across the industries. It can be found in manufacturing, in data lakes, in anywhere where you need this expandable, reliable, simple storage. So now what I'm going to do, I'm going to go through a bunch of architectural diagrams. Please don't freak out if you see like a little bit more complex architecture diagrams for the first time, but this is the reality. You're never going to use like one particular service without any context around it. And what I'm trying to do now is to just give you a little bit of a context how you can navigate those diagrams. So diagrams basically can be found also on AWS reference architectures. So they are publicly available. If you're gonna work with your customer, you'll end up with something like this. This is gonna be your solution for one or another problem. So let's see how we navigate this one. So this diagram, for example, here offers video on demand on AWS. So this, of course, offers more than, it consists more than just S3. S3 is one integral part of it, of course. Here and here you can see it. The first thing I would suggest how you can navigate the diagram, try to find where it all starts. Many times you will have, those numbers like 1, 2, 3, and so forth. This is how the data flows, or these are the interactions inside the system, what kind of happens, like in which sequence. Try to find where data comes in or what triggers the system to do something. So here it's numbered and it's kind of easy to do, but in the most diagrams, it's somewhere on the left. So here, for example, the source, this is where data comes into the system. And as you can see, data kind of gets video from somewhere and stores it in S3. And the whole solution, what it does here, it grabs the video, converts it to different media formats, and then serves it to customers. So if you get like original video in your system, you start this whole, sorry, the wrong direction. You start this whole flow of different things. And then at the same time, when you're done, you don't need to keep this video in a kind of hot storage. You don't need to have like frequent access to it. So you can then upload it to Glacier, to Amazon S3 Glacier. This is what Ashish was talking about. Now, you can maybe even for now disregard what happens there inside this bigger picture, like step functions and so on. Maybe we will come later to those things in next sessions. Basically, what it does, it takes the media file and converts it using some particular services like Media Convert, for example. And then it brings it towards the delivery. So this is where our customers or users will gonna consume this video. So this is this part, the delivery in the end. And then again, Amazon S3 is one of the central services there. And Amazon S3 will deliver we'll deliver the data, those videos to end users, not directly this time, but via Amazon CloudFront. So Amazon CloudFront is basically a content delivery network, CDN. It will just cache the S3 content, and then through Amazon network, it will upload it to edge locations very close to the end users, and thus users will consume those files and from CloudFront. So this is one architecture. The other architecture I can present to you now is basically this one. This is in the world of accessibility. So you can design an application using this solution, which will read, read on screen things and then read it out loud. So it's kind of accessibility feature for visually impaired people. So how can we use it? Again, let's find first of all where it all starts, because otherwise, like, too many things going on in this diagram, right? So the first thing here on the left is where users interact with mobile application. So this is a mobile client, these are users. Now we have a little bit of a mental concept for how this whole thing kind of works, right? So our users, they have mobile phones, right? Now from mobile clients, you will invoke AWS SDK. So it's just a bunch of libraries to communicate with services in AWS. One of the services we have here is S3, and S3 is also quite core service here. So first of all, you need to serve the application to the client. So then the application going to be like, files and static content and stuff like that. That's going to be our front end. In the front end, you might have a couple of other things, like, for example, Amazon Cognito for authentication, authorization, but then Amazon S3, you can use it for hosting your website, right? And then the other part here is, so we see here is like, clearly there are two parts of this system. And the second part of the system will kind of do the backend work, the heavy lifting, the machine learning, if you want, bit. We don't need to understand all these services here, but basically what they do, they would get the image from the screen of the user. They will convert it into the text, and then they will translate this text if necessary. And then with Poly, this is a voice generation service. They will create audio files, and then those files need to be stored somewhere. And again, you go to S3. So you see, it's completely different use cases, even inside one system, but we still use the same service. So you can't really work around and not gonna use S3 in your diagrams. And maybe one other example here. You're gonna get the slides, don't worry, and you can also walk later on a slower pace through those diagrams and see how it all works for you. So here, for example, we have a whole bunch of S3 buckets here in the bottom layer, and those are kind of interconnected with CloudFront. But in this particular scenario, CloudFront is not serving so it's not for downloading objects from S3, it's actually for uploading objects. Again, you can then utilize this end locations in CDN, in CloudFront, so that your data will travel not through the public internet, but through AWS network. Thus, the upload of the file will be faster. So I'm not going to go into this particular diagram any further, and let me just go out from the full screen and see if there are any questions I can pick up. All right, Ash, so how are we doing on time?
We are good. We still have 5 minutes, so if you want to use it, you can. Otherwise, you know me that I can talk for 1 more hour.
Yeah, isn't it our job to talk for hours and hours?
Exactly.
Right. Okay, so yeah.
If you want to share something, feel free, Alex. Otherwise, I can summarize and give some links to the participants so that they can practice it again on S3 and some more resources I can talk about.
All right, just do your thing, and if there are any questions, I'll then pick up them from the chat. Okay.
Good. Okay, give me a minute, everyone. And hope, thank you, Alex. Thanks, Jamila. It was interesting to see the side of the picture where customers are using services like S3. And what I'm going to explain to you now that what are the additional resources you can take help of to understand things in much better format. So let me quickly go through that, and I'll explain you the some of the stuff which you should be learning and preparing if you want to get more details on it. So let me bring one document. It's a Word file, and we will upload these document into our resources page. So you would be able to see this into the section. So what I'm going to give you today as a homework, as I like to give my students, that I would be giving you some videos which you can watch. So you can watch these videos, which is for reInvent, as we see here. Then there are videos for getting started with Amazon S3. So if you are just getting started, this video is very right for you, very small one, and tells you what needs to be done and what are the options available. Then read this general FAQ section. So here we talk about what are the basic stuff you should be aware about when you are utilizing Amazon S3. So that stuff would be available into S3 general FAQ. Plus, I'm also going to give you some service summary card for Amazon S3 and Amazon Glacier. I'll walk you what these service summary cards in a minute. This I created, and I would be sharing that with you. Plus, if some of you want to practice on what we discussed, so there is a free quick labs where you can go register through your email address, and you would be able to you will be able to practice creation of a S3 bucket, some basic stuff around it. So they should not be a problem. So that we will be talking, you can take on that. Another one, if you want a little bit more practice, then there is a free tier where you can go and create your account, how to create and activate your account, those information is there. And for someone who wants to like master S3, master object storage, we have created a free 11-hour training on storage. This training you can go through, and there is a test at the end, and that test will give you a badge which will make you a storage expert or object storage expert. So this is a nice training, little lengthier, but goes in very detail if you are interested. Maybe not fully we want to watch, maybe at least some of it. So please go and check this training. I would also give you ramp up guide on storage, one stop solution for learning about storage. And we run these free training event officially as a AWS as a company. So check those also. Then in the reference section, I am going to give you some more details like bucket policy example, how charges work in Amazon S3, multi-part upload. If you have to do, like if you have a big file, you can't upload it one time, you may want to use S3 multi-part upload, some storage classes, lifecycle policies associated with that, and then Amazon Snow Family. Snow Family is a physical storage devices, so a little fancier service in case you want to decide that, hey, I have a lot of data and I cannot move it over internet, and I want to move it over physical devices. So we give you those physical devices too. These are called Snow Family devices. So here we have Snow Cone, which can give you around 8 TB of data. Then we have Snowball, which is a big size server, which can give you 50 to 80 TB. And then 100 PB of data would be available if you want to transport using Snowmobile, which is your basic example. So these links will be shared on the BeSA resource page. There is a resource section, and in that we have week 1 resources. We would also put week 2 resources, and if we could, we would also put it on the YouTube channel videos link references. So that would be there also. So multiple places you can find it on resource page and on YouTube video. I would say resource page is better because we may update it if there is a need for it. So that depends. So Bash has a question. Snowmobile is only available in US currently. I would say it depends. So we do not physically have that resource right now, but if there is a customer use case, we can give it to you. So you have to request, and then we will do a study. We'll see how we can facilitate, and we can obviously give that snowmobile to you. So it not physically may be present, but it can be ordered for other location, and depending on the feasibility, AWS would be able to give it to you. Now, the reference card which I have created are like this. So in one single slide, I'm trying to talk about basic stuff of that service. Obviously can't cover everything, but I'm talking about like what S3 is, why somebody would use it. Then we would say when, where, who, how, and how much. So yes, Keith, it depends, right? So that's how we am giving you this summary card. You can use that. That is for Amazon S3. And similarly, I have created for Glacier. So very basic stuff to get started, that how these services work together, what you should be worried about, what you should be thinking about, how much the cost is, who would be responsible for doing what. So this summary cards you would also find in PDF format into the BeSA website. So you can check it from there. It may take little time for them to be get updated, maybe in an hour or two, or maybe by tomorrow maximum we will get it published for you so you can study it. So hope everyone enjoyed. If you like the session, share on LinkedIn, let other people also know so that they can also get benefited, because registering for session is easy. Attending session at odd time on Saturdays is really tough, and we appreciate you all being here. So spread the word, let other people get benefited so that we can help as much people as we can. Thanks everyone. Feel free to reach out if you have any details questions to ask. We would try to respond as much as we can, but in case your question got buried in our LinkedIn messages, feel free to remind us and we would be happy to answer back to you. This is the link where you can find the BESA resource page, and hopefully you enjoyed, and I'll see you next Saturday, and hopefully we'll have more interesting stuff. If you have any questions, feel free to send across, and we would be trying to help you with those things. So thanks Alex, thanks Chris, thanks James, thanks Jamila. It was interesting, and hopefully everyone was able to get some value out of it. So till next Saturday, take care, be safe, talk to you next Saturday. Thank you so much.